Have you ever wanted to access your friends or your parents' network from your home network? Ever just wish they were somehow joined without using additional software on your computer? What this describes is a site-to-site VPN, and in this video, you'll learn how one works and how to set one up. Welcome back to Dev Odyssey, a developer's journey through IT, where I cover tutorials and reviews of IT tools and technologies. I'm your host, OpenWrt, and in this episode, we're setting up a site-to-site VPN using OpenWrt and Wireguard. Before we get into making a site-to-site VPN, let's get a better understanding of what one is. A site-to-site VPN is a connection between multiple networks. This doesn't really sound much different than the regular use of a VPN. What differentiates them is the way that they're used. A VPN is most commonly used to tunnel your internet connection through a VPN server. You can check out that video I made in the card above me. However, a VPN can also be used to connect remote networks together, thereby allowing you to access these networks just as if they were your local home network. Let's take a look at a diagram to get a more visual understanding. In this diagram, we have two local networks, Site A and Site B. In these local networks, we have two computers, Workstation A and Workstation B. In its idle state, the WireGuard tunnel does not exist. Rather, it sits silently, waiting to receive a connection. When the WireGuard interface receives a connection from the internal network, it then initiates a handshake to the other WireGuard peer that the traffic is destined to. Once that handshake is established, the tunnel is then created, and connections are sent over the tunnel. The receiving peer then takes the incoming connections and routes them to their final destination. Once traffic has stopped, the tunnel remains active for 2 minutes. After 2 minutes of inactivity, the tunnel stops and a new handshake is required to initiate the tunnel. Let's demonstrate this with an example using Workstation A and ping. Workstation A initiates a ping to Workstation B. The ping then travels to Site A router. Site A router sees Workstation B's IP address and then looks at the routing table to see where to send the ping. The routing table says to send the ping over the WireGuard interface, and the ping is then sent to WireGuard. The WireGuard interface receives the ping packet, then checks which peer to match the packet to, in this case Site B router, and then initiates the handshake with Site B to create the encrypted tunnel. Once the encrypted tunnel is established, the WireGuard interface sends the packet over the tunnel to Site B router. The Site B router receives the packet, decrypts it, and checks where to route the packet using the routing table. Then finally, the ping packet is sent to Workstation B. Lastly, to send the ICMP echo back to Workstation A from Workstation B, the same process happens in reverse, except this time a handshake does not need to happen. Workstation B sends the packet back to Site B router, which then gets sent to WireGuard to encrypt the packet, and then sends it over to Site A router. Here the packet is decrypted, then is routed back to Workstation A, where it receives the ICMP echo. Regardless of what side the ping is initiated, it will work the same in both ways. However, this process is slightly different when using a persistent keep alive. In this scenario, one of the WireGuard interfaces will send a small packet to its peer every 25 seconds. This is done to keep the tunnel active. So when the traffic is sent over the tunnel, a new handshake doesn't need to occur. The process continues from here in the same fashion as noted earlier. The benefit to not using a keep alive is it keeps the protocol silent, and therefore, WireGuard ports are not likely to be seen as open when being scanned. In addition, WireGuard only responds to encrypted packets it can decrypt. Otherwise, any traffic sent to that port that the interface cannot decrypt simply gets dropped. The biggest benefit to using a persistent keep alive is when WireGuard interface is behind a carrier-grade NAT. Since you cannot do port forwarding rules on a carrier-grade NAT IP, the persistent keep alive ensures that you have and maintain a tunnel with the peer. Site-to-site VPNs are most commonly used in corporate networks to connect multiple remote office networks together, as if these networks all originate from the same firewall. This improves the functionality and security of corporate networks, where you can access network resources as if they were local, from behind the firewall, as opposed to exposing them publicly and accessing them from outside the firewall. These same benefits carry over to small business or personal home networks. If you have a small business, you can manage the network remotely from your home network. Or if you want to manage a friend's home network or a parent's home network, you could do that too. In addition, you can set up the site-to-site VPN so that all devices are accessible from all of the connected networks. If you need more security, you can also implement firewall rules or different VPN configurations to prevent access to certain network ranges, effectively allowing you to customize the site-to-site VPN to your needs. For this video, I'll be using the following: 2 Raspberry Pi 4s running OpenWrt 21.02, Wireguard, a Netgear R6080 router running OpenWrt, and 2 Ethernet cables. Before we begin, I'm going to quickly explain my setup. First, I am not connecting this over the real internet. I am simulating the internet using this Netgear router that will hand out random public IP addresses to the Raspberry Pis. This allows me to show you where the public IP addresses go in the VPN configuration. These are not my public IP addresses that I control. All of the VPN configuration shown will apply to any setup you want to do over the real internet. And all the concepts in this video apply to any real-world scenario. The focus of this video will be on the site-to-site VPN configuration with an OpenWrt with WireGuard. As for the Raspberry Pis, they'll represent our home routers. This one we'll call Site A using the IP address of 192.168.1.1, and the other we'll call Site B using the IP address of 192.168.2.1. These will have pre-configured networks with the necessary packages, including WireGuard, which can be found in the description below. The IP addresses for the VPN network connecting these routers will be 10.10.10.1 for Site A and 10.10.10.2 for Site B. Just to note, the Ethernet ports on the Raspberry Pis will be acting as WAN ports, and all the configuration will be done connecting over Wi-Fi from each Raspberry Pi, labeled Site A and Site B. With all that out of the way, let's get started. First, connect to Site A over Wi-Fi. Then from here, I'll log into Lucy at 192.168.1.1. Once we have logged in, we'll navigate to Network, then Interfaces. Here, click Add New Interface. In the pop-up, label this interface Site_A. Then click the Protocol dropdown and click on WireGuard VPN. Next, click Create Interface button. In here, click Generate Key button. This creates the private key for our WireGuard interface. Then, assign the listen port to 51820. This is the default port for WireGuard, but you can change it as you please. Next, set the IP addresses to 10.10.10.1/32 and hit Enter. Click on the Firewall Settings tab and click Create Assign Firewall Zone. Label this as VPN. Then click Save and Save and Apply. To continue, click Network at the top, then Firewall. Under Zones, click Edit next to the LAN zone. Then, in the drop-down for Allow Forward to Destination Zones, add the VPN zone and click Save. This allows LAN traffic to cross into the VPN zone, allowing any LAN-connected device to communicate across the VPN. Next, edit the VPN zone. For the drop-down, allow forward to destination zones, add the WAN zone, and click Save, then Save and Apply. This allows VPN traffic to cross into the WAN zone. This change isn't necessary for the site-to-site VPN to work, but if you plan to connect other devices to the VPN, this could be useful for accessing the internet through the router, just like the default VPN use case. Instead of using a VPN zone, we could have chosen to use the LAN zone. However, using a dedicated zone allows for more granular security controls on the zone, such as firewall rules that you can keep separate from the LAN zone. For the next step, click on the Port Forwards tab and click the Add button. In the pop-up, give it the name WG. Click the Protocol dropdown and select UDP. For the source zone, choose WAN. For external port, type 51820 or a port of your choosing. For destination zone, choose VPN. For internal IP address, use the Wireguard interface IP address 10.10.10.1/32. For the internal port, use the Wireguard listen port 51820 or the port you chose earlier. Then click Save, then Save and Apply. Lastly, we're going to get some information and hold on to it for configuration of Site B. First, go to the home page by clicking Site A in the top left-hand corner. Toward the bottom, you will find the WAN IP address. In this case, it's 86.45.69.6. Copy this and put it aside. Second, go to Status at the top, then click Wireguard. From here, copy the public key of Site A, as you'll need that for Site B. Now, we're going to change over to Site B. For me, I'll change over to Site B Wi-Fi I have set up. We'll log into Lucy at 192.168.2.1. Here, we're going to repeat the exact same steps with minor differences. I'll highlight those as I go along. Go to Network, then Interfaces, and click Add New Interface. Name the interface Site_B. For protocol, choose WireGuard VPN. Click Create Interface. Now, click Generate Key to create a private key for this WireGuard interface. For listen port, we'll use 51820. For IP address, this will be different from Site A. We'll use 10.10.10.2/32. Click the Firewall Settings tab, and then create a new firewall zone called VPN. Next, click on the Peers tab. This is new, as we haven't done this on Site A yet. This is how our WireGuard interfaces know to validate and to connect to each other. Click Add Peer. For the description, name it Site_A. For the public key, paste in the public key that we copied earlier. For allowed IPs, we're going to put in two networks. First, type 10.10.10.0/24, then hit Enter. This is our VPN network. Next, type 192.168.1.0/24 and hit Enter. This is our Site A LAN network. Moving on, check off Route Allowed IPs. This is a very important step, as it will automatically create the necessary routes so that our local networks on both sites can communicate with each other. If this is not done, your networks won't communicate. In addition, be sure to write the correct routing notation using the appropriate network identifiers. Otherwise, the route will not be made and the connection will not happen over the VPN. Here, this setting will create routes to the VPN network and Site A LAN network. For endpoint host, use the public IP address of Site A router we saved earlier, 86.45.69.6. For endpoint port, leave it blank for default or type 51820. This is the external port we used when doing our port forwarding in Site A. Lastly, for this peer, you have a persistent keep alive. What this does is it sends a network packet every 25 seconds. This keeps the WireGuard handshake alive. It isn't necessary for the setup that I am doing. However, in some scenarios, this is needed. If the network you are connecting from is behind a carrier-grade NAT, where you don't control the public IP address, then you want to turn this on. This will make sure that the VPN connection does not stop. In doing this, you lose the silent security benefits of WireGuard, as I spoke about in the diagram earlier. So for me, I'll skip this. Once done, hit save, then save and apply. From here, we'll head on over to network, then firewall. We'll edit the zones just as we had earlier. Click edit next to the LAN zone. Next, click allow forward to destination zones dropdown and choose VPN, then click save. Then edit the VPN zone. Next to allow forward to destination zones, choose WAN and click save. Then click save and apply. To continue, click on the Port Forwards tab and hit the Add button. Name it WG. For protocol, choose UDP. For source zone, choose WAN. For external port, choose 51820. For destination zone, choose VPN. For internal IP address, use the IP of the WireGuard interface, 10.10.10.2/32. For the internal port, use the listen port for WireGuard, 51820. Then click Save, then save and apply. Since we've made all these changes, let's restart the WireGuard interface. Click on Network, then Interfaces. Next to the Site B interface, click Restart. While it restarts, let's go to the home page by clicking Site B in the top left-hand corner and find our public IP. In this case, it's 205.79.33.106. Copy this and save it for later. Then we'll also need the public key of our WireGuard interface. Under Status, click WireGuard. Copy the public key and save it for later. Let's connect back to Site A to finalize our configuration. Log back into Lucy at 192.168.1.1 if you still aren't logged in. For me, I'll just go back to my old tab. Next, under Network, Interfaces, click Edit next to Site A interface. Click the Peers tab all the way to the right, then click Add Peer. For description, call it Site_B. For public key, paste in the public key we saved earlier. For allowed IPs, we're going to put in two networks again. First, type 10.10.10.0/24, then hit Enter. Again, this is the same VPN network as before. Next, type 192.168.2.0/24 and hit Enter. This is our Site B LAN network. Next, check off Route Allowed IPs to create the routes to the VPN and Site B LAN networks. For endpoint host, use the public IP of Site B router that we saved before, 205.79.33.106. For endpoint port, leave blank for default or type 51820. For persistent keep alive, we can leave this blank as noted before. Click Save, then save and apply. Lastly, with all these changes, let's restart the Site A WireGuard interface by clicking the restart button next to it. If all goes well, our site-to-site VPN should now work. To test this out, I'm going to do the following. Since I'm connected to Site A, I'll ping Site B VPN and LAN interfaces first. Let's ping 10.10.10.2. This indicates we're able to connect to Site B VPN interface. Let's check if the routing is working by pinging 192.168.2.1. Let's do one more ping test to a device on Site B's LAN network with the IP of 192.168.2.50. Great! The response shows our routing rules were set up correctly. Additionally, we should now see RX and TX traffic for the interface when looking in Lucy. Lastly, we can check for handshake under Status Wireguard. As you can see, we have a successful handshake. All this confirms the connection is in order. Lastly, let's visit Site B Lucy interface to make sure TCP traffic is working over the VPN. Let's try that now by browsing to 192.168.2.1. Awesome, it works. Let's try visiting Lucy using the Site B VPN IP of 10.10.10.2. Cool, this works too. Now, let's reverse this and connect to Site B Wi-Fi and do our pings and Lucy connections to Site A LAN IP and the VPN IP address. Pinging 192.168.1.1 works, and so does 10.10.10.1. Let's ping a device on Site A LAN with the IP of 192.168.1.50. As expected, we get a response. Let's try Lucy on Site A. Looks like we can access Lucy over both IP addresses, confirming it's all working. And that wraps up our site-to-site VPN configuration using Wireguard and OpenWrt. As you saw, setting up a site-to-site VPN doesn't have to be that complicated. It can be done securely and easily with great benefits. If you need to host data off-site onto another network, a site-to-site VPN can help you offload data. If you have a media server, like Plex, hosted in another location, a site-to-site VPN can ensure you can stream video to your local network. These are some of the main benefits of a site-to-site VPN, and I'm sure you can come up with many more. My final thoughts I'll share is that this VPN configuration is done with best practices in mind. But there are other ways you can set up a site-to-site VPN. First, if you don't want to use WireGuard, you can use OpenVPN or IPsec. Those options have been around for a while and used for many VPN configurations, for the business and personal use alike. Being more feature-rich than WireGuard, they can easily get more complicated. Getting back to my preference of WireGuard, you can use the same setup I showed and tweak it to only have one site initiate the connection and maintain it with a persistent keep alive. This means you don't have to write a port forward rule on the initiating server. I still prefer the method I showed as it's not as chatty, but this is an equally viable option. So if that sounds like a setup you prefer, give it a shot. I'll be here if you have any questions. Thanks for following me in my journey. I really appreciate it. If you got some value out of this video, go ahead and give it a thumbs up. And if you like this type of content and other content around IT technologies, networking, security, and more, go ahead and subscribe to my channel and click that bell for notifications so you don't miss the next video. Want to see a site-to-site VPN without using a custom router, such as a Raspberry Pi OS or another Linux distro? How about with OPNsense or pfSense? Maybe using OpenVPN? Drop me a comment below so we can discuss it. Thanks again, and I'll see you in the next video.